Right then, the next concept to look at is sections. So sections is defined as a non-iterative work-sharing construct that contains a set of structured blocks that are to be distributed amongst and executed by the threads in a team. What does that mean? Well, we define a pragma area of sections within a parallel region, sections plural, and then within that we define one or more sections. Each of these sections will be executed by one thread, and they will be divided up into the team that comes in. I say executed by one thread. Let me explain. Each section will be executed once, and will be executed once by a dedicated thread. If we had 100 sections and 10 threads, then obviously threads are going to execute more than one section. Effectively, this is the same as loop iteration, but we are manually specifying the blocks of work. So each of these sections within this section header will be divided up and distributed amongst threads. So let's have a look at this code. So we start off our usual start parallel region, hello from thread, and give the thread number, and then we define the sections header. Within here we're defining two sections. So first section we're going to print the number of the thread executing it and say that it's going to sleep for 2 seconds, and then we will sleep for 2 seconds, and then we will say the thread in this section has finished sleeping. The second section we will say the thread executing it, but we're not sleeping, we're just carrying on, and then finally we say goodbye from each of the threads, and then the parallel region is finished once we've joined again. So to recap, each of these sections is a discrete piece of work. It's the equivalent of having them in a list in a for loop or whatever. These are to be executed by the thread team. Each section gets executed once. So we have two sections, two threads are going to be given these pieces of work to do. One of them in the first section will sleep for 2 seconds, the one in the second section will not. Okay, so they all say hello at the same time. First section is being executed by thread 1, sleeps for 2 seconds. Second section is being executed by thread 5. Note they start at the same time. And then nothing else happens until the thread in the first section is finished sleeping. Again, sections, implicit barrier at the end. So at the end of the sections, we're waiting for everything to be finished before we move on, say goodbye from threads. So wait 2 seconds, and then there we go. This time, the first section, thread 3 executes it. Second section, thread 2. And so on and so forth. So, master, I only want one thread to execute this, and I want that to be thread 0 in all occasions. Single, I want this piece of code to only be executed once by one single thread, but I don't care which one it is. Sections, I want each of these individual pieces of work to be executed once by whichever thread is free to do it, and maybe each one will be executed by more, or each thread may execute more than one section if the number allows it, and then we go through. Implicit barrier at the end, but we can override that as with master and as with single by using no wait at the end. So this is very useful when we perhaps want to do a set of iterations, set of setups to go. We could have a whole bunch of single sections all with no wait on them. But by doing this and by using OpenMP sections, we're able to then use the workload scheduler exactly the same as we would with anything else. So a very powerful way of handling code where we want to divide this up and make power of the threading engine without having to actually worry about the underlying thing, without having to create a list, without having to put them into some sort of queue. We just literally can have these things, each one divided up, and we know that they will be divided by the team and worked upon.